Hello, welcome to the New Stack Makers, a podcast where we talk about at-scale application development, deployment, and management.
This week we're in Austin, Texas for the South by Southwest Festival. Specifically, we're at the Capital One House at Antone's. And all week we're going to be recording podcasts with some of the brightest tech visionaries that are attending this event. Hello, this is Joe Jackson from the New Stack, and welcome to another edition of the Makers Podcast. This week we're at South by Southwest. We're camping out at Antone's. We're working with Capital One. They got some new releases coming out, and we're going to be doing a weekend of podcasting here. And our first guest is a machine learning expert, Inmar Givoni. Thanks for taking time to talk with us.
Absolutely, it's my pleasure.
Excellent. Now, Inmar had done a really popular session this morning on machine learning, a kind of introduction to machine learning, and we've been kind of delving into machine learning at the website, and so we wanted to find out more about what you know and what you could share with our audience. All right, first of all, let's dive right in. How did you, now you have a background in software development, but how did you get pulled into machine learning?
Right, so actually this story goes quite a way back. When I was in high school, I thought I really wanted to be a neuroscientist. I thought the brain was the most interesting question out there, understanding how the brain works. So I was determined to go to university and study neuroscience. Because I'm from Israel, in between high school and university, I went to the army, and I was trained as a software developer there. So for a couple of years, I worked as a software developer. I really enjoyed it, and then I thought, okay, it's time to go to school, and I still hadn't forgotten about my neuroscience stream, and I enrolled in a computer science and biology program because I thought these are two good things to know about. So my third year of undergrad, I took a course in machine learning, and I thought, wow, this is so awesome. I love the math. I love thinking about problems in this way, and maybe instead of trying to understand the human brain, I can work on building computer software that kind of tries to mimic the brain. And then I decided to pursue it further, so I moved to Toronto and went to the University of Toronto and got a PhD in machine learning.
All right. So you're one of the rare machine learning experts who actually has knowledge of the biology of it.
Yeah, which is interesting. I mean, right now the most exciting area in machine learning is deep learning. And deep learning has the intuition or motivation for the algorithm coming from the brain and neurons and how they work and how they connect to each other. So just like in the brain, in the human brain, we have neurons that take in inputs. They receive signals, electrical signals from other neurons, and then they decide whether or not they want to emit a signal, which is called, the terminology is to spike, right? A neuron spikes and sends a message to the neighbors. So artificial neural networks, and deep learning is a type of artificial neural network, do the same thing. They receive information. You have an artificial neuron that receives information from other neurons and then emits some sort of a signal. So the motivation is based in the human brain.
Right. Excellent. Now, something I'm very curious about, how is programming for machine learning or deep neural nets, how's it different than regular software programming?
So first of all, it's fundamentally a different way of thinking about problems, because as a software developer, if I told you, why don't you sit down and write a program that will help you to take images of dogs and cats and tell me, is this a dog or a cat, right? So as a software developer with software development background, you'd probably do something, well, I need to describe what a cat looks like and what a dog looks like. So, if it has eyes and a nose and whiskers and so on, right? Machine learning. Yeah, a lot of if, and you're going to try and capture the rules, and you're pretty quickly you're going to find out that it's impossible. There's too many rules, too much variation, and maybe you yourself don't really know what it is to be, what it is that your brain is telling you when it's saying, oh, this is definitely a cat or a dog. Machine learning takes a completely different approach, which is you take a lot of data, you take a lot of images of dogs and cats, and you feed it into the algorithm. And the algorithm knows this is a dog, this is a cat, and what the algorithm is trying to do is to figure out the rule by itself, so that now when you show it an image and you don't tell it what it is, it's going to say, okay, this is a dog based on the information. And this is why it's called machine learning, because you're learning from data. So the availability of data and knowledge is really fundamental to machine learning.
Excellent, excellent. And so I guess there's a kind of supervised and unsupervised mode. Like you could kind of prime systems to say, look for these things that are like dogs, or you could just.
Right. So in a supervised setup, we basically, to use the dog and cats example, we say, okay, here is like 10,000 images of dogs. Here are 10,000 images of cats. Now learn some rules to allow you to make the next, inference, the next decision. In an unsupervised setting, you're like, here is 20,000 images, and you have to figure out how to divide them up. I'm not going to tell you anything about it, but there has to be some pattern in the data that allows the algorithm to say, well, all of these things kind of look similar, and all of these things kind of look similar, but they're dissimilar from each other. So that would be the unsupervised learning. Supervised learning is understood much better nowadays than unsupervised learning, in the sense that we have a whole suite of algorithms that have been performing better and better. And over the last 3 to 5 years, you can see a lot of examples where within supervised learning, the performance of machine learning algorithms has surpassed that of humans, right? So you give the human the task, you give the computer the task, and the computer does better. And we see it in these simple tasks of image recognition and object detection and speech recognition and so on. Unsupervised learning still has a long way to go, but people are definitely very interested in it because it's clear that this is one of the next frontiers.
Nice. So now you're currently, I know you can't say much about it, but you're currently director of machine learning at Kindred. But your LinkedIn you have a lot of fascinating experience. I was kind of curious about what you did. You were at Microsoft Research.
So during my PhD, I did a couple of research internships. So this is pretty common for PhD students in computer science in general, and in machine learning in particular, to go and spend a summer or a term in some research lab. And Google, Microsoft, Facebook, they all hire a lot of PhD students, and they all also hope to maybe recruit them as full-time by the end. So I did 2 internships. One was with Microsoft Research in the Valley, so they used to have a research facility there. And what we worked on was application of machine learning for e-commerce, and the question we were looking at is this was for selling stuff on Bing, right? Sure. So Microsoft had a system where it had a catalog of items. These are all the things that we sell, and these are the prices. And merchants would send in descriptions of the same items, right? And how much they want to sell it for, so that when you go and search for something, Bing can show you, here are all the merchants that sell this particular thing. Now the problem is every merchant was describing the item in their own different way. Nikon camera F7 with blah 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 black, and the other one would say black camera made by. So there was no form that was strict about how they describe, and you needed to go and take this string and match it to some catalog item. So that was basically defining and finding the structure and using some machine learning algorithms to make a correct or as good as possible a match between these unstructured strings to the catalog. The next internship I did was in Microsoft Research in Cambridge, England. So we were working, that was right after the Kinect gaming system was brought to the world. And within the Kinect system, again, there is some very sophisticated machine learning algorithms used. One example is, the Kinect system has a depth camera, which basically tells you instead of a regular image where every pixel is red, green, or blue, in a depth image, every pixel is just how far from the camera is the object, right? So if I took an image of you, there will be a bunch of pixels over here which are closer, and then there is the wall. The problem was, how do we go from this representation to knowing where each limb in your body is? Because the Kinect system needs to know where your hand is and your legs and your head, so that it can do the matching between what you're doing to the game, right? So I worked on part of the system so they had some basic system that was really good set in place, but the system was not resilient to all types of edge case behavior. For example, if you were standing on your head, it wouldn't really get it right, because it made strong assumptions about your head supposed to be over over your shoulders and so on. So we worked on a problem like that, and that was also a lot of fun. So that was my experience with Microsoft Research. And then after I graduated, I worked at Kobo. So Kobo is some Canadian pride. So it's a Canadian e-reader company. So selling e-readers like Kindle. And also it has a website where Kobo sells books and so on. And it has a self-publishing platform, so anyone can become an author and publish on the website. So there are a lot of machine learning problems a lot of machine learning algorithms and tools that can be used for various problems that a company like Kobo has. So one of them would be a recommendation system, okay? So you buy a bunch of books, kind of like Netflix. We want to start recommending you what would be the best next read for you. Another example would be, which is something I talked about earlier today. So we needed a system to determine whether a book has pornographic material in it or not, right? Because that's really important for a company to know. You don't want to send certain information on email if you know the book is pornographic. You don't want to put it on your top web page. So we worked on a system like that. Other examples include improving the experience for the user who goes to the website. So maybe for you there is a version of the website that targets your tastes and preferences, and you see the different sales in different positions. Whereas for someone else, it would be a slightly different variant of the web page. So these are just some of the problems we worked on. So there was definitely no shortage of things to do with machine learning. And I can say a little bit if you want about Kindred. So now that machine learning is getting such good results and there is real progress being made, for me, the next frontier is how do we take machine learning and robots and put them together? Because it's one thing to be able to solve problems in a virtual setup, like images, everything is in a computer, you don't need to interact with the world.
Point of view is very flat.
And it's completely different if I put something here that needs to move around, and as it touches things, they'll topple over, it interacts with the world, it changes the world as part of the interaction. It's a very active type of thing as opposed to, the passive machine learning, which kind of just looks and gives an opinion. And robots are hard to deal with. It's hardware. Hardware is hard. Ask anyone in software that has to deal with hardware. It's a different story. So for me, being able to teach robots to be intelligent is kind of where I see a lot of effort going in the next few years, and that's why I found it a very exciting opportunity.
Actually, it must be kind of tricky because I remember Rodney Brooks. His idea was to make robots as stupid as possible, but physically build them for their environment. But it sounds like you're going to be doing a little bit more. You're going to have to add some sophistication.
Yeah, because I feel like if you look at creatures that are actually mobile in our world, like anything from a spider they all have some sort of neuron processing, right? Maybe if it's not a full brain and they don't have a cortex, they still have, that's how we differentiate, right? So plants don't move around. So as soon as you add locomotion and interaction with the environment, it seems like you need some processing power, right? Which is why I think that to me at least, it doesn't make a whole lot of sense that you can just make robots very, very stupid and expect them to display very intelligent behavior. Yeah.
It also sounds from your experience that machine learning, it's almost a domain-specific sort of thing. It seems like you can go into any market and you can find where machine.
Yeah. So that's another interesting thing that's happening right now. I think everyone is kind of catching on to the idea that it's not just for Facebook or Google. And there are a lot of applications everywhere. And even now, I think, if we look through the apps that you have installed on your phone, you might be surprised. There is a lot of machine learning in there already, right? You open up your mailbox and some of the stuff gets tagged as spam mail, right? You don't see it. It gets put into your spam box. That's machine learning. We talked about recommendations. So, pretty much on any website now that sells you something or a service, there's some form of a recommendation telling you, you might prefer this. This is machine learning. You talk to, I don't know what kind of phone you have, but whether it's Siri or OK Google, you're able to talk to the phone, ask questions, right? So the speech processing and the question answering, these are all machine learning algorithms. You can translate, you can find faces in images. All of these applications are machine learning, and they're already around, so people don't think, oh, that's a big deal. But we're going to see more and more, and it's going to get into pretty much any area that you can think of in businesses and industry.
Is that is that going to have some challenges for the machine learning expert in the fact that they're going to increasingly have to know the specific domains?
What's interesting is that there is this trend, and that happens, I think, in science in general, which is it used to be the domain of experts. And you really needed to understand the mathematics and how to write code for these mathematics, which is tricky, and really dig into the fine details. But now there are platforms that, open software platforms, open source platforms that people have put together, which are very resilient and very powerful. And so you no longer really need to understand what's inside the black box, right? This is kind of like back in the days, maybe everyone needed to know how to program in assembly, right? And if you didn't know assembly, what are you going to do? But now, who cares, right? Because we have these high-level abstractions, and we don't really need to understand what's happening below because the abstractions are so good and so powerful, right? And so the same trend is happening in machine learning. So companies like Google put out software services like TensorFlow, and there are a lot more. I'm just giving one example. And people are using them as a service, as a black box, without needing to know too much. They need to understand the basic problem they want to solve, what is the data that should go in, how to look at the result in terms of performance, and maybe a few tricks, but they don't really need to seriously go into the low-level details. So it's transforming the industry. I mean, I think there is still room for experts to develop the next wave of algorithms and tools, but there is a lot more room for practitioners.
Nice. Now, I wanted to switch topics a bit. You do a lot of outreach efforts to get young women into computer science.
Right.
I know it's a bad problem. It seems to be getting worse, which is crazy. I mean,
there is a lot of people are concerned about it. There is a lot of I guess money that goes into solving the problems from companies, from industry, government, and yet it doesn't seem like we're moving fast enough and radically enough. I feel the problem starts really, really early. So, for example, the toys, even the toys and books people bring to babies, right? It's pink, you're a princess, you don't need to think, you need to be beautiful, right? This is like your value proposition to the world. I just saw this really clever video of a mother and daughter going through a shelf full of books in a library, probably a few hundred books. And then they started by removing any book that doesn't have a woman in it, any book where the woman doesn't have any aspirations. And at the end, if you're looking for a young girl, what are the books that she can read where it's about her being smart and innovative and creative? There is nothing. So, and then it goes into high school and university and so on. So for me, because I do have the perspective of graduate school and being a researcher in industry, I try to target, this group of people as much as I can. So I'm involved in several initiatives. One of them is called Women in Machine Learning. So it's basically a group of fairly senior women in academia and industry who organized an annual event in one of the biggest machine learning academic conferences. So every year we get any woman who wants to come to join us for a day-long conference, and it's been getting increasingly popular. So when I organized it myself quite a few years ago. So it's been running for 10 or 11 years. So I organized it the third year. And I think we had maybe 75 participants, right? Last year I participated and so just a couple months ago, there were over 600 participants. So that's really nice to see. I also do outreach presentations to university students, to high school students. And basically the idea is I tell them what I do, I tell them what was my path, and I also tell them honestly, it wasn't like it was easy or trivial for me. I think a lot of it is perseverance. A lot of it is just, getting through the tough spots, having some mentors and friends to support you. And I think anyone can do that if they really set their mind to it and are willing to sit down and study hard and work hard.
Excellent. All right. Final question. As a machine learning expert, do you believe in the singularity?
You know what? I don't think I have a good answer for that. I think there are a lot of really smart people out there, and they have very different opinions about it, right? So clearly, it's not an obvious yes or no. I like the idea from a philosophical point of view, and as a science fiction, geek. I like the idea of eventually being able to upload our, consciousness or whatever it is to a computer. I like the notion of maybe being able to, live forever, to experiment with anything. So I think it'll be fun. Whether or not it's coming next year or coming at all, I don't know.
All right, Inmar, well, thank you so much for taking time to talk with us.
Thank you very much, and have a good day and enjoy the rest of this festival. It's fun. Okay, thanks.
This week we're in Austin, Texas for the South by Southwest Festival. Specifically, we're at the Capital One House at Anto's. And all week we're going to be recording podcasts with some of the brightest tech visionaries that are attending this event.